All right. Hi, my name is William Shaddix, and I am a CXL Solutions Architect at Micron. And I'm here to present our work on graph analytics over disaggregated CXL memory, along with our partners over at Pometry. So, a little bit about why we're looking at graphs, particularly with CXL. Graph codes tend to have very large data sets and also very irregular axis patterns, which doesn't work very well on traditional block devices that might be used once our data set gets bigger than memory. A little bit about our test setup. So we are using Pometry's graph database workloads, and then we are running it on our CXL chassis that has 256 gigabyte CZ122 modules. We have 22 of them there, giving us about 5.5 terabytes of memory, of CXL memory. And then we have 4 CPU servers that are all hooked up to this via a CXL switch. So another thing is we're using our fabric attached memory file system for this, which allows us to use any code that previously would have just mapped into files to read and write to their data set, and just put this all in CXL without having to change the code at all. In this case, our graph data set is a read-only data set, so we're able to have all 4 servers sharing it without having to worry about synchronizations and things like that. So first thing we notice is when our graph fits entirely in memory, this left side here is showing, or the blue graph is showing NVMe, but in this case, when it fits all in RAM, it's all in local memory. And the right side is our CXL over FAMFS. But when it's under our 1 terabyte of local memory, we notice performance is the same, even when CXL is being used for the FAMFS side with about 5x latency over the local DRAM. But the second we get over this 1 terabyte of local memory, we see CXL and FAMFS starts performing about 40% better when we have a 1.2 terabyte data set. And when we scale it up to 4.6, we see about a 25x improvement in performance. The other thing we want to make sure is that we can scale this out well. So here on this plot, we're showing 4 different servers in this green, blue, orange, and red down here that are all going on at the same time. And they're each pulling about 18, 19 gigabytes a second from their CXL link. And then we see that this scales linearly through all 4 of these servers, potentially meaning we could scale linearly further, or with workloads that demand less bandwidth, we could have 8 or 16 of these servers connected to it if there's enough CXL ports, and expect linear scalability. Thank you.